And you've just completed an investigation, so I want to see what would be somebody's definition for a central angle. What is a central angle? Somebody just go ahead.
Angle whose vertex is the center of the circle.
Okay, an angle whose vertex is the center of the circle. Any others? That group back there, what do you get for an angle? Central angle. Okay, point where vertex is in the center. Vertex is at the center of the circle. There you go. Pretty straightforward. We've already talked about central angles. Biggest thing you need to understand about a central angle. What is the root word of central? Center. So that should automatically tell you that's an angle centered at the center of the circle or at the center of the circle. Okay? All right, inscribed angle. Okay, so let's go to another part of the room. A group back there, what'd you get? What do you think an inscribed angle is? An angle with each point touching the outside of the circle. Okay, what about that group right there? What'd you get?
My group?
Yes.
Angles that are inside the circle.
Okay, so let's see, angles that are inside a circle. Vertex is on the circle and the sides are chords. Okay, the vertex is on the circle and the sides are chords. What that does is that tells you the angle has to be inside the circle when it says they're a chord. Okay. So now what we're going to do is we're going to go ahead and complete these investigations. And what I did to save some time for you is I went ahead and copied off some circles with centers already marked. So we can go ahead and leave out that step, and we can go ahead and jump to the next step. So first of all, you've got a large circle. It's already been constructed for you. Okay? So now it says label the center O. There you go. So just pick one of them. You're going to use 3 of the 4. So if you screw up one, you've got an extra one. Construct 2 congruent chords in your circle. So this is a suggestion. You can use a ruler to do this, and that would work as well. But what you're going to do, okay, is you're going to take, and what I would do is I would just pick a chord some distance here, and I would pick it like an even measure. So I might pick like a chord of 4 inches. Do you see that? And draw that in. So if I pick this one at 4 inches, I'm going to come to the other side and I'm going to do the same thing. See if I can get a chord of 4 inches. So that would be a way that you could do that. If you've got your protractor, measure that way. But you are looking for 2 congruent chords in the circle. Now when you get done with that, you will label those chords A, B, and C, D. Okay, notice how they're labeled here in the diagram. A, B, and then C, D. When you get those labeled, A, B, and C, D, it says construct radii, OA, OB, OC, and OD. So basically take the center and connect all of those dots. We're on this one. So now, depending on how you've drawn it, some of you, like if you look at Clay's right here, his look like his are parallel, so his angles are going to look a little different than Aaron's here. Okay? And so what I need you to do right now, okay, is I need you to go ahead and measure this angle right here and this angle right here. So go ahead and measure that center angle right there. So you're going to measure this angle here and this angle here. So what'd you find out? Yeah, they're somewhat closer. You might have gotten them within a degree or two depending on how you drew things in. So they might not have been exactly the same, but they were, somewhat fairly close. Okay, so we have a conjecture now, and that's the chord central angles conjecture. The chord central angles conjecture. If two chords in a circle are congruent, then they determine two central angles that are congruent. Good job. So when you get that written down, you can go ahead and start writing down the chord arcs conjecture as well. And then we're going to fill in the blank on that one. So go ahead and get those two written down. What do you think will go in the blank on the chord arcs conjecture? And their intercepted arcs are congruent. It's dealing with arcs. Okay? So if two chords are congruent, their central angles are congruent. Also, their arcs are congruent as well. Okay, so let's go ahead. Oops, I think I skipped one. Did I? No, I did. Okay. So here we go. What we're going to go ahead and do is we're going to look at investigation 3. It says in this investigation you'll discover relationships about a chord in the center of its circle. So you've got another circle. I've already given you one. Mark the center. Construct two non-parallel congruent chords. So these are the ones, some of you already did that on your first one. You'll just have to duplicate it again on the second one. But make sure that they're not like parallel, so somehow slant them a little bit. Okay? So construct two non-parallel congruent chords. Now notice what it says. It says, then construct the perpendiculars from the center to each chord. Okay? So you have got your nifty little protractor. You can go ahead and use that instead of actually using your compass. Okay? But you are going to construct the perpendicular, so 90 degrees. So basically what I would do if I were you, take your protractor, set it along that chord, move it so that the 90 degrees will actually be in line with the center. Go ahead and draw those through. So the perpendicular. What did you notice then about those segments after you drew the perpendicular in? What does the perpendicular do to each of those chords? Bisects them. So there you go. The perpendicular from the center of the circle to a chord is the bisector of the chord. So once again, that's going to be kind of important in some of the diagrams we're going to be looking at. And then finally, two congruent chords in a circle are equidistant from the center of the circle, which means they are the same distance. Okay, I'll let you get those down and then we'll move on. Okay, so let's go ahead and look at this next one. Got your third circle. It says construct a large circle, mark the center, you already have it. Construct two non-parallel chords that are not diameters. Okay? Two non-parallel chords that are not diameters. Now, here it doesn't say that they have to be the same length. So basically, you're just drawing two chords in, okay, that are not parallel. So you don't have to measure them or anything. Then construct the perpendicular bisector of each chord. So this would probably be the easiest way. Okay. What you're going to do is measure, if you can, the length of, well, actually another way you could do it to find the bisector. Remember, you can fold like we did using patty paper. So if you fold that chord over on itself, you should be able to fold right along that, and that'll create the perpendicular bisector. So you won't even need to measure. Let's go ahead and fold that like we did with patty paper. And so go ahead and crease it the whole length of the paper. Do that with each chord. What do you notice about your folds? Where are they through? The center of the circle. So the perpendicular bisector of a chord passes through the center of the circle. Okay, now it might not have been exactly, it might have been off just a hair. Okay, but you should have gotten them fairly close to the center. Now it's important you get the names of these conjectures down because on problems 1 through 10, they're asking you to state the conjecture that supports your conclusion. Okay, and you're going to need to do that. Okay, so your assignment then is going to be found on pages 320 and 321, and it's going to be to do numbers 1 through 12. And like I said, on 1 through 10, it asks you to write the conjecture or the name. So chord arcs conjecture. Okay, another one was the chord central angles conjecture. Those are going to be the conjectures you're going to be looking at to justify your answers. So for Monday, 1 through 12,